This video is about page 4 of the notes packet. And today we're going to be talking about Lewis dot symbols for ions. Okay, so if you recall from a couple months ago, we learned about cations versus anions. So a cation is a positively charged ion, and an anion is a negatively charged ion. And you should recall that an ion is just a charged particle or charged molecule, charged atom, okay? It can either have a positive charge or a negative charge. So cations occur when metals lose their valency electrons. So their Lewis symbols are actually going to contain no dots, but they will show a positive charge as an exponent to the right of the symbol. The reason why is because once metal atoms lose their valency electrons, their ions technically still have 2s and 6p electrons in their new highest energy level, right? That next shell down, okay? Which still satisfies the octet rule. So here's an example. If we're talking about strontium. If you don't remember electron configuration, you need to go back to one of my old videos, okay? But basically, the electron configuration for strontium is as follows. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and then finally 5s2. So its Lewis symbol, we know that strontium's in the alkaline earth metal, so it's in that second column. It's only going to have two dots around it, two valence electrons around it. But when it becomes an ion, it's going to get rid of both of those electrons, okay? Which means we're kind of just going to get rid of that 5s2 there. So the ion electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. And now the ion's Lewis symbol is going to be rid of those extra pesky valence electrons, and it's going to have that cute little charge, that positive charge. Okay, so here's something interesting. What noble gas is this electron configuration? So if you look at your periodic table and you go look for where 4p6 is, you'll realize that this has the electron configuration of krypton. Okay, remember, atoms want to be a p6. They want to be like noble gases. And by getting rid of those two valence electrons, strontium just became like one of his buddies, krypton, which is exactly what it wanted. All right, so that's cations. Anions are going to be very, very similar, just kind of an opposite process, I guess. So anions occur when nonmetals gain more valence electrons. So Lewis symbols will contain 8 dots for these, and they will show a negative charge as an exponent to the right of the symbol. Again, makes sense. If you're adding more negative things, you're going to become more negative. So once nonmetal atoms gain electrons, their highest energy S and P orbitals are full, satisfying the octet rule, right? They finished their collection. They needed one more electron, and they got it. So an example here is fluorine. The electron configuration of fluorine is 1s2, 2s2, 2p5. Oh, it's so close. Okay. Fluorine is a halogen, which means it's going to have 7 valence electrons. It really, really wants that last electron to be like a p6. So what fluorine is going to do is it's going to go find a way to get another electron. And what ends up happening is when it's an ion, it becomes 1s2, 2s2, 2p6. Ding, ding, ding. That's exactly what they want. So its Lewis symbol finally has that perfect, beautiful octet that's stable. And so you're going to kind of draw it like that. And if you go look at your periodic table, the noble gas that ends at 2p6 happens to be neon. So you need to understand how to do these symbols in order to be able to draw ionic bonds, which we're going to talk about tomorrow.